Hey, what's up YouTube? Today we have a viewer request on a teardown for a 3D Sega Saturn controller.
Patented by Sega.
Apparently, the viewer took his apart and cannot seem to put this back together. Today we're going to be using a regular standard number 1 JIS screwdriver. You can find these Japanese JIS screwdrivers over at Amazon. This was a Vessel brand. You can see the ball head here, which makes the ergonomics really great for taking off screws, obviously. So here we go. 4 screws on the back, or it's like 5 screws. 1, 2, 3, 4, 5. By the way, the Japanese 3D controller is the exact same as the American 3D controller. For the cord, this pops loose, the edge is tabbed, press down on the tab, pull out at the same time. You can see it connects via, this is a PCB board that goes into the port here. You can see here, the rubber pads are standard rubber pads. These are only compatible with the 3D controller. And this is the switch here to switch between digital and analog. Here's the main PCB. We can further tear this down by removing the triggers and removing these screws right here, which are number 1 screws. Again, you can use this number 1 screwdriver. And here's the tab to push, and this will release. And you can further tear this down by removing the PCB here that connects to the board by pulling on this tab here and pulling the PCB out at the same time. You can see this tab just engages that hole right there, and then the same thing for this trigger here. Okay, the last piece that you can take off is the actual analog stick by just pressing on the tabs here, and it'll release. Press and push down at the same time. Again, pretty simple. So that screw is going to be the smaller screw. We're going to try, again, this is a JIS screwdriver. I'm going to try this number 0. This doesn't seem to have a logic on it, so it's just a connector PCB. Okay, just giving some extra information here as far as controllers go. This is true for the Sega controllers, or the Sega Saturn controllers. The inputs going into the multiplexer or the encoder on the controllers are actually logic high, meaning 5 volts going to the inputs of the again, the logic circuit. When you press the button, it actually brings that input signal low to 0 volts. Again, in the digital world, it's actually 5 volts for a high and 0 volts for a low, or 5 volts for a yes, 0 volts for a no, 1 and 0. And there are pull-down resistors here. You can see the resistors here. All these are pull-down resistors, but you can see it on the 3D logic board. Obviously there's going to be more processors dealing with the analog triggers and stick. And if the screw feels really tight going in, reverse screw the screw. That way you don't mess up the plastic threads going in. Comparing both triggers, they physically looks the same, so I think you can mix and match these. If you do get them mixed up, put this in first, the square edge. You see the triangle edge, which you push down on. The square edge just uses it as a lever, so you put that in first. Same thing for the other trigger. Now when pushing down on here, try not to push from anywhere, but as close to the tab here as possible, so you don't weaken the other parts and maybe snap something off. For the analog stick here, there might be a sticky pad underneath here that you might have to use some glue to actually get this back on. If you do try and take this apart, so this is the furthest I'll go. You can see this can actually go 1 in 4 ways because the 4 tabs are all identical. but there are these small little nubs here that go into these two holes. So the orientation is one of two ways. It can be obviously this way or 180 degrees this way. So make sure you get the nubs into the holes. Always when repair, do a little inspection to make sure everything's fitted correctly. And before I go, I'd like to again say thank you to all the subscribers, all the new subscribers. Also for those that comment. As you guys can see, I try to respond to every comment that's made on the channel. And with that said, I'll see you guys next time.